Do you have a mic that I can walk around with? Thank you very much.
He also leads the innovation and business development effort at MPA with a specific focus on navigating and growing the international new space economy. He is here today to share with us his insights on vast and various applications for AI and autonomy in space. Please join me in welcoming Rohaan Ahmed.
Thank you. Hello, everyone. I've got more wires here than a real robot running through. So can everyone in the back hear me? You're fine? All right. Safa, can you close the door, please? So it's day 2 of a conference, 3 p.m. Everyone's got conference fatigue setting in. I know I do. Sometimes I just want to take a nap at this time. But don't worry, we're about 6 hours away from a championship, so we should be good. All right, let's go. So I'm here to talk to you about the applications for artificial intelligence and autonomy in space. Particularly, I'll be focusing on a vast range of topics where AI is currently being used. As we go through this presentation, you will realize that it's still very nascent. We're still trying to figure out how, autonomy has always been a part of space, but how is intelligent autonomy becoming relevant? And my hope with this talk is to actually have you guys think about the projects that you're working on in your organizations and your research institutes as a student, whatever, and actually see how you could apply that to help us in the space industry complete our tasks. So I'm going to talk about something right off the bat that tends to be the focal on the first day of pretty much every space conference that you go to, and that's this idea of new space versus traditional space economy. I'm going to tell you what the climate is currently like, and I'm going to go into several applications related to space. Now, what qualifies me to talk about this? Well, nothing really. I just applied. But, I've had the good opportunity to work on a breadth of different projects in space, including one that I'm very proud of that's going to launch next year called the ExoMars 2020 rover. It will be the first European Mars rover, and if this is successful, hopefully, Canada will be the second country in the world to have its locomotion system traverse the surface of Mars. So it can be a moment of great pride for us. Furthermore, I'm working on what we call the Lunar Deep Space Gateway, also known as the Lunar Orbital Platform. You guys might have heard about it. It's the stepping stone to going towards what we call deep space. Think of it as the next International Space Station. I worked on multiple on-orbit servicing projects, applications for VR and AI in space, and then a whole bunch of innovation and innovation strategies. Now, prior to the 2000s, the space was the domain of defense and government. Everything was big, large. Corporations, even private commercial corporations, were companies like Lockheed Martin, Boeing, etc. You had these one-off missions, mostly these one-off missions that took a long time to come to fruition. Additionally, cost a lot of money, and usually they were driven by drivers from government and defense needs. And there were really 3 tiers of players. There was the United States and Russia. There was other countries like Canada, Europe, etc. And then there was a 3rd tier, which is the rest of the world. Now, however, things are changing, and you guys have all heard of this company. Actually, maybe you haven't heard of it. This little company startup called SpaceX. It's a very good example of what we would call a new space company. Space is going to grow. People realize there's a lot of money we made in commercial space. And so space is expected to grow from a couple $1 billion economy to a multi-trillion-dollar economy over the next few decades. And it's all being driven by commercialization. So what I mean by that is large institutions such as the Canadian Space Agency are no longer interested in funding the entire mission. They want to buy they want to buy the end product, they want to buy a service, they want to buy, for example, images of the Earth. And then other companies, investors will go in and they will actually generate the capability and build the capacity to do that. Risk previously used to be, primarily on the government, taxpayers, so all you guys. Thankfully now it's on the investors. It's pretty much shared across the board. So if a venture fails, if a project fails, those companies have to answer to their shareholders, so it's a lot more capitalistic. Sorry. And then now there's fewer barriers to entry because we're using lean manufacturing technologies to try to drive costs lower, as well as deregulate a little bit. And so just quickly, as I said, there were a few key players in government. Now there's a whole bunch of other countries that are in it. UAE, Australia, UK, they're all investing millions and billions of dollars in their space industry, Canada included. Everyone wants to be a major player in space because there's that commercial aspect of it. And then there's literally hundreds of VC applications that go out every month, and dozens of them get awarded, and they're all related to space. So it could be anything from launching to commercial satellite constellations to generating analytics and data from captured images, etc. Now, you can't go through a week really in space right now without some amazing breaking news happening. So I thought this was going to be the new thing that I was going to talk to you about, the radar shot cancellation. Anyone here watched the launch yesterday? There's 3 people. Well, Canada yesterday took a major step towards becoming pretty self-independent in our satellite Earth observation needs. We sent up 3 satellites on board a SpaceX Falcon 9 that will now be able to image most of Canada and most of the Earth when we want it to. I thought this was going to be the big news, and then this morning coming in, I read India says they're going to launch their own little international space station. So I thought, wow, that's cool. Like I said, you can't go a week in space without some breaking news happening, something big, and which is why it's so relevant to this conference here, because you have now these two industries that are growing at a rapid pace. So let's get to the point. AI, particularly autonomy, but AI in general in space is driven by the following factors. The farther away you go from Earth, the greater communication delays are. So in low Earth orbit, when you're talking about the International Space Station, it's negligible, which is only for about 450 kilometers away from us, from the surface of the Earth. When you go to the Moon, the delay time is about 2 seconds plus processing, so it can be about 3 seconds. When you're talking about Mars, you're talking about 6-minute delay. And so the further and further away you go, the more autonomous, the more intelligent the stuff that you send there has to be. On top of that, there is no satellite system on Mars that can give you 24-hour communication. Therefore, sometimes you can have dropouts that last from hours to months. So you need to be able to send systems running. Right now, the stuff we have on Mars is basically collecting samples very slowly. It took 14 years for the Curiosity rover to cover 48 kilometers. If we want to colonize Mars, we cannot continue at that pace. We need these rovers, we need these things to be faster and more autonomous. So in addition to delays, communication delays, we also have radiation issues. And once you go beyond LEO, you're bombarded with radiation. And you also have very complex systems that need to work together. And as I'm sure everyone here understands that the more complex the systems are, the more intelligence need to be built at the interface level. And then finally, we have some constraints. Sending a kilogram to space costs money, and a cubic centimeter costs money as well. So anything you send to space has to be low mass, low volume, and low power. And that adds to the constraints, which we currently don't necessarily have with our cell phones. So the number one area where AI and machine learning has made the most headway in space is in the realm of satellites. So what you see here, for example, is, and then I'm sure a lot of you guys understand right away, is data collected from these Earth observation satellites, and now we're doing feature extraction. Why is that useful? Well, countries, companies, organizations want data for different reasons. Governments want it to, quell illegal immigration. They want it to patrol their borders. Companies might want to know just to see what's happening around where the traffics are at certain areas. We collect over hundreds of terabytes, if not petabytes of data every single day. And this is a number I'm making up, but about 95% of data is mundane information that we don't really care about. It's that 5% we need to extract, and that's where deep learning comes in. So let me tell you a little about this. So this little project right here was a Microsoft project made by a couple of interns that can look at an image in real time and extract roadways and buildings, etc., which is useful. But what we really want is something like this. So up here we have before and after images of a disaster that happened in Brazil, which unfortunately resulted in the loss of life. We want to be able to use Earth observation data to save lives. We want to be able to predict these sort of things. Here we have, down here we have a flooded plain in flooded delta in Texas, which hopefully, as we build our capability, we'll be able to evacuate people a lot quicker. I mean, thankfully there was no loss of life, but we can evacuate people and help the common good. There was a talk upstairs going on about about AI for social good, AI for good. Well, this is a classic example of that. Now it's well and good when you have images from top and you can see, compare. But what happens when you're never at, so when in a disaster scenario, you will almost never be at the nadir. You will never be at the point where you can get the perfect image and compare it with previous images. So one of the problems that we're having now is how do you deal with images that are taken off nadir? How do you deal with images that have shadows on them? And how do you incorporate them with in our these life-saving data collection events? Just a quick point, there was a company not long ago, I'm not going to name the company or what happened, but there was a company not long ago that was able to defeat their own Earth observation deep learning machine by having inserting a bunch of images of kittens, and the model recognized it as mountain ranges because that's the only thing it knew how to do, is try to make sense of it and say, well, it's a mountain range. So you can tell it's very, at the time it's intelligent, but it's also very silly. Another area where there's a lot of demand for AI going forward is robotics, particularly in this case, on-orbit servicing. So we're talking about when you send up a satellite into space at the moment, the minute something goes wrong with it, you have to kind of throw it away. So imagine buying a BMW every time you want to go somewhere, and then as soon as something goes wrong, you have to throw it away. Millions of dollars get wasted. So there's this idea of on-orbit servicing where you can go refuel, repair satellites while they're in space. Well, for that you need intelligent robotics. You need autonomy to do it once, and you need artificial intelligence to be able to do it regularly and repeatably in a reliable fashion. Another issue related to that is space debris. A lot of you people might know about it. Actually, some of you might know about it, but it's gaining some traction now. What essentially happened is at the start of the space age, we did to space what we did to the waterways at the start of the Industrial Revolution. We started polluting it without really thinking that space was too big for us to really make a difference. Well, now we have a problem because if you look at this graphic right here, we've polluted our near low Earth orbit quite a bit. And if you look at this graph, the majority, I'd say about 80% of the stuff up there is debris, stuff that we don't have a use for. It's not operational satellites. And so one way that we want to continue sending things up into space. By the way, the number of satellites is supposed to double. Oh, sorry, more than double. Right now, there's something like 5,000 satellites total up there operational. SpaceX alone wants to put up 6,000, right? Amazon was to put up another 6,000, something like, or 3,600, something like that. These constellation satellites will add to the problem. So by the year 2020, we might have 20,000 operational satellites plus a lot more rocket motors, discarded rocket motors and debris that we will have to deal with. And there will come a point where we'll no longer be able to send things up in space without having to, truly build them so that they can withstand debris. So one way to do that is to remove that debris autonomously using robotics. You can't go to a space conference right now without having at least one paper or one talk on this subject. An area where we might think that AI doesn't really have much of a role to play is launching rockets, except that if you look at the bottom left, that's the amount of human resources and physical resources that are required when you're at a mission control when you're launching a rocket. With AI, we can boil it down to essentially one desktop computer. And that's what companies like Amazon Web Services, Ground Station, and JAXA are trying to work on. By the way, this image has nothing to do with mission control, but I just find it so beautiful, the way space. It's like rocket science meets ballet. If I was a SpaceX employee, I would have this as my screensaver, but since I'm not, I have other things. Another project that I have had the good fortune of working on is the Deep Space Gateway. So this is a commitment by mainly the United States that we're going to return to the moon by 2024, and we're going to build a station around the moon that we can then use to go beyond. And now there are 2 countries that have already joined as partners, Canada with a $2 billion investment, and Japan. Now, if we want to establish a base and do smart things and do good things on the lunar surface, we want to be able to do them quickly, efficiently, in an intelligent way. And again, so you want to be able to send a command at a high level. Right now, when we want to capture, for example, on the International Space Station, when we want to capture a Crew Dragon vehicle, which is a SpaceX vehicle that goes up with the supplies, actual human controllers at control stations on the ground have to fly the tip of the robotic arm on the International Space Station, which is what my company MDA built. They actually have to fly it and capture it. Well, on the moon, we will not have that luxury, and we will have to just tell the arm to go capture a vehicle, and then it will have to figure that out on its own. So as you know, computer vision is fundamentally an AI problem, but well, there's also the planning level above that. Similar is true for Mars. If we want to colonize Mars, like I said, we need intelligent robotics. We need to be able to send things up there that can work on their own without having to tell them at every moment what we want to do. And then eventually we want to be able to do what we call insight resource utilization. So you guys might have seen videos or pictures of concepts, people coming up with how to 3D print habitats on Mars. Well, you're not going to be able to do that if you don't have intelligent robotics. Space mining, I like talking about this because this is probably the most sci-fi thing. There are objects flying around that are flotsam and jetsam from the creation of the solar system that are actually worth billions of dollars, if you put it in Earth money context. There's an asteroid by the name of right there, Ryugu, which is about 1 kilometer across and is estimated to have value of a profit value, not revenue, profit value of about $30 billion US. So if we were to be able to go there and then bring back the stuff and use it, it's worth 30 billion. I mean, it sounds like a made-up word, really. We're going to go capture a satellite. We're going to go capture an asteroid, and it's going to make us $30 billion. But hey, somebody did the evaluation, and I'm going to present it here. So Japan already has one of the probes, Hayabusa 2, up there, trying to collect samples, trying to see how we can do that. Well, you're not going to send astronauts. You're not going to send humans to asteroids. You're going to need robots. You're going to need satellites. You're going to need, in fact, intelligent satellites that talk to each other and fight each other. I know that's a joke, but it leads me well into the next slide, because when you have these resources, when you have space, so space has been an active warfighting domain forever, since the dawn of the space age, the Cold War, for example. But now it is actually an active warfighting. So you have satellites up there that give you information that your enemies, whoever they might be, do not want you to have. And so we have things like the anti-satellite weaponry. You guys have heard India tested recently an anti-satellite weapon. They destroyed their own satellite, created 400 pieces of detectable debris. That's detectable as anything over 10 centimeters. So 400 pieces of debris that were over 10 centimeters, some of them above the altitude of the International Space Station. So that's a PR disaster, by the way. That's not good, because if the ISS gets hit by one of those pieces of debris, that's not good for India in terms of image. We have anti-satellite weaponry. We have, so when we were sending satellites up into space in the 80s, the 90s even, there was no encryption. We were able to we just downloaded data, the way you would over Wi-Fi or whatever. And now we're becoming aware that this data can actually be used against us. Now there's attention to cybersecurity in space, and so these are wonderful ways in which human beings do the thing we do best: is fight each other in the space domain. And lastly, what you see on the top left there is the current robotic workstation on the International Space Station. This workstation, all that hardware and mass, controls just the robotic arm. Obviously, that's not efficient. So what we're doing now, there are currently projects flying on the ISS that are, think of it as Alexa for the ISS. They're powered by IBM Watson, for example, in this case, that are designed to assist the crew in doing their tasks, day-to-day tasks for station keeping. Additionally, we're looking at developing AR, VR capabilities that would give you situational awareness and allow you to control multiple robotic elements. So, for example, when you're on the habitat in that cislunar station, you can actually you would be able to control the arm, external arm, internal arm, a rover on the lunar surface, a satellite that's outside, using the same interface, the same control. And this is something that I've had the good fortune of working on recently, and I just think it's really cool because it's probably you talk about space alone, it's great. You talk about space and AI, it's better. You talk about space AI with goggles like these, now you feel like you're in Star Wars or something. So it's amazing. And hopefully, I was trying to keep it on time. That brings me to the end of my maiden presentation. I do want one more minute of your time, for a personal note. And now we're all here because we are lucky enough to have had opportunities in our life that have led us to this point. In terms of education, most of us, I hopefully had a good nurturing family to bring us here. But there are currently, I forget the number, 4 million or something like that. Every 2 seconds, a child somewhere in the world is orphaned. And I work with this charity, that's a federal charity here, in Canadian registered charity, that provides education opportunities for these orphans around the world, so that we can motivate these children to become the next major STEM researchers and engineers who solve problems on a day-to-day basis. I'm not here asking for money or anything like that. All I'm saying is please keep this in mind, that there are children out there that need our assistance and care. And if you have some time this afternoon, please visit the website and consider reading about it. Thank you very much. I'll take questions now. Thank you. Yes, sir, please.
I'd like to know whether there are some unique aspects of AI in this specific domain you should know.
Can you?
Like the other participants talk about AI in other industries, in more related to finance.
Yeah.
And you're talking about satellite.
Yes.
Those.
Yes.
There are various industries. Are there any unique aspects of that?
Well, fundamentally, I think the algorithms that you guys that are used in finance for pattern recognition and data extraction to extract analytical information, fundamentally this should be similar. The application is different in space. I can't think of anything in particular other than the constraints that I've talked about, because when you're typically working on here on ground, you don't really have to give as much consideration to things like radiation or mass and volume, I'm assuming. Whereas in our case, those tend to be the driving factors. So you can't, for example, the robotic computer that controls the Canadarm2 is a much weaker processor than anything you guys have on your device right now. You cannot, right now, there is no way that I know of to put any sort of high-level detail autonomy on a processor that is qualified for space, for all that radiation. I don't know of one. The most up-to-date processors tend to be in the realm of 600 megahertz with I don't remember the exact numerical data, but they're not useful enough right now, powerful enough right now to be able to do the computing we want to do. So that's a challenge that we're facing. I hope that answers some of your question. We're trying to piece it together so that we can implement it in a distributed fashion so that we can do individual tasks intelligently without having to come up with a processor that's non and recurring engineering cost that is powerful enough to do everything. I really hope that answers your question. Yes, please.
What is your typical day as a mission system engineer?
My typical day? Well, I go It varies, but I get to do a lot of front end facing with the customer, which is something I really enjoy. So hopefully in a week or two, I'll be going to England to talk to one of the satellite manufacturers, and then immediately after, I'll be flying to the Netherlands to talk to the European Space Agency, and that's. I mean, I personally, because maybe people are different, but I love traveling for work. So especially when it's to like Germany and Europe, I don't enjoy so much going down to Tucson, Arizona, but when it's to the Netherlands, I don't mind. On a given day, I will be interfacing with 2 or 3 different customers in the West Coast of the U.S. and in Europe. I will be leading a team to do so I'm a system engineer. A lot of people don't consider system engineers, but I do. We're the technical sort of the head, and we direct people we do the architecture, and then we direct people on the more detailed design when required. I don't really have a typical day because every project is different. We have some projects that literally are $100,000 a study, and then you have projects like the Lunar Gate, which is a $2 billion project. So it varies. Yes, sir.
Could you talk a little bit about what you are doing specifically and MDA is doing with respect to the LPG? Like, what are you guys working on? It's just.
I mean, that's a great question, but you have no idea how difficult it was for me to tell my company that I'm going to be coming here and talking about that, because that is supposed to be very IP. Okay. It's not just my company; it's the government of Canada is very hush hush about it, because we don't want a new company to come in and be like, hey guys, we can do that too. Right. So thank you. I apologize, but yeah, they don't want me to say too much. In fact, if you saw that slide, I only had a little bit of information. Yes, sir.
Are there international regulations on the deployment of satellites in terms of being able to recognize other countries, who's out there, and standards on what you can put out there?
Yeah, so you do have to.
Weaponization, which is an obvious risk.
Yes.
I've heard about electromagnetic radiation, just to take out the grid,
Yes.
things like that. Are there any controls?
No, so there's no. It's a bit of a wild west. There's guidelines, and if you put into space something that people don't like, you're going to notice. It's not like you can launch something without other countries noticing. For example, when India launched the anti-satellite weapon, the United States knew about it within seconds, right? And
how do they know what was put out there in terms of capabilities, weaponization, etc.?
oh, so the exact details of the actual satellite put up is, for example, if you put up a satellite that has of a certain size, you can make judgment about what it might be, but there's no guaranteed way of knowing what it is. So, I mean, if you're referring to satellites that might be sent up there with the specific purpose of being weapons, that might already be the case. There's no way of guaranteeing knowing. You can disguise it as a surveillance satellite. You can disguise it as just a regular geobus. But it is a bit of a wild west. Even with the debris, you'll notice that there's no guideline. There's nothing that says that if you put something into space, you have to bring it down. You have to be responsible for the junk that's created. There's guidelines, yes. There's guidelines, but there's no law right now that says you need to do it. So imagine you're a company like SpaceX or OneWeb or Amazon that is thinking of putting 4,000 satellites into space. You're basically being told that it's a nice-to-have feature right now that you're going to deorbit your satellite, but you don't really have to. There's no law saying how you must. It's in development phase. So we have the ability, as you can see on the International Space Station, we have the ability to grab stuff. All right, that we can do. But can we grab? I don't know of any robotic mission that went and grabbed the satellite and brought it down with it yet. But that is, it will happen within the next 10 to 15 years. It has to happen, I think. There are, by the way, these satellites that go up. They do have. So a lot of these satellites do have the ability. So just before their fuel runs out, they put themselves in what they call graveyard orbits, so less trafficked orbits, and then that's a nice way of graceful shutdown, but nothing in particular that way. Yes, sir.
How do you collaborate in terms of like the space warfare, like you say the military? Like is it just we make this thing happen and then you guys take care of it, or you have this issue, you fix it, like, or is it just you're mutually exclusive? Like how does that work?
So how does my company in particular work with the
military and the security and the space warfare aspect? Yeah.
So I would say the Canadian Defense is one of our primary customers. So the radar shot constellation that just went up is not just for Earth imaging for agricultural purposes. The Canadian Armed Forces want the ability to see and communicate in remote areas in Canada. In fact, they were one of our primary customers that we talked to. We build the capability that they want. When it comes to specifically to space weaponry, there's not really much I can say about that. But any country in the world, when they want to build anything like that, they will go to their local experts for that.
And then you would just like me to say like air command system officers or some sort, or what? Like,
Oh, so you're talking about who in the military specifically controls it? Or who?
Like you could discuss with like axles and just say, yeah, this is what's up, and like other.
So there's a training that happens. Yes, once we have so people who look at Earth data, there's training that happens that initially initiates within. So the military, you initially get trained. You train a certain set of the military, and then they train everyone else. Right? They build the capability, and they train everyone. They have a very the military is very good at training. And, so yes, air combat system operators are there's 2 locations in Canada right now, and where they do space warfare courses, and I believe the controls are ACSs. Yes, sir.
Did you see a more trend moving towards cube satellites?
Yes.
Do you think that's where things will be going?
Yes. So the satellites. One thing I guess I forgot to say is that traditionally satellites were big, and they were getting bigger and bigger, and then suddenly now we're getting smaller and smaller. So most satellites launched now, most of these constellation satellites are the size of let's say a washing machine and smaller. So CubeSats are actually, yes, they're great instruments for. In fact, CubeSats are one of the only satellites that can be launched from the International Space Station itself. They tend to be more science focused. There's a company in Toronto, I believe, Kepler Communications, that launches a satellite that's about this big, and they want to provide internet. But other than that, yes, CubeSats are a big deal, but I don't know whether they can give you the capability of, for example, when it comes to communication in Earth orbit, Earth observation, that other washing machine size satellites can give. But washing machine size satellites are still considered small sats. By the way, you guys, I should have had a picture of the 60 SpaceX satellites that they launched in a row, right? You see how they were stacked up? Oh man, that was something. Like, can you imagine something that you manufacture that's each individual is worth like $5 million, and you just stack them on top of each other like that? Yeah. Well, apparently it's communicating fine, so. So one last, okay? Yes.
With more and more private companies entering into this space, do you think there's an impending need for regulations? And I know NASA runs a sort of certification program for private companies now who are entering into this space.
Yes.
Do we see any more coming up?
So the funny thing is that there's more focus on deregulation in the U.S. than there is on regulation, because they want people to invest and they want people to go up. So there's committees that are formed where the purpose is almost to reduce the barrier to entry, which is good in a way because it brings in more money in the industry, but it's bad in a way because now, like I said, it was a wild, wild west, but at least back in the day, you had to be a strong cowboy. Now anyone can do it, right? I do believe that sooner or later we're going to get more regulation in terms of space debris and what can be sent into space. But right now, I mean, one of the slides I had, how the NASA has released a plan on commercializing the International Space Station. Essentially, they will allow commercial travel, commercial astronauts. So one of you guys, if you can afford it, can actually go up to the International Space Station and live there for a few days as a tourist. Soon, it'll happen. Do I have time at all? Or am I done?
Have to go for a break.
Okay. I apologize. I'm told my time is up. I'll stand outside. You guys can ask me questions. Thank you very much.